This question was given to us by Mabutla Matejo. Mabutla, thank you. It's a nice question. Nice trick right in the beginning, and I love these. I love these. This whole question was for 11 marks. It's 5 marks for the first, then 3 marks for the second part, and 3 marks for the third. Okay, they tell us the following. We have a figure, a cubic curve, which is represented by this equation. D is a turning point, and so is F. A, B, and C are x-intercepts, and E is a y-intercept of the curve. Now, they ask us to show, for 5 marks, show that P is minus 5 and Q is minus 4. Now, folks, there's 2 things. There's a P and there's a Q. Usually, if we want to find 2 variables, or 2 unknowns, rather, then we need 2 bits of information. Let's see, do we have? The only thing we have on our graph is this point over here. But remember, this point here is not just a point on the graph, it's a very special point. It's a point on the graph, plus it is a stationary point, if I can abbreviate it like that. So that means there's 2 things happening here. They've given us the coordinates of the point, which is straightforward. F is 2 and minus 9. And then they said that this is a turning point, or a stationary point, which means that at that point, the gradient is 0. And there's your 2 bits of information. So write it down. For number 1, we're firstly going to use f of 2 is minus 9. Okay, that's our first bit of information. So if we use this, then our y value becomes minus 9. So minus 9 will be 2 times, the x values are all 2, so 2 squared plus, 2 cubed rather, p times 2 squared plus q times 2 plus 3. The second bit, we're going to say, okay, the derivative at this point is 0, but we'll get to that now. Okay, so if I clean this up, I get minus 9 is equal to 8 times 2 is 16, plus 4p plus 2q plus another 3. 16 plus 3 is 19. If I kick that over, it's minus 19. So I get minus 28. A little bit of arithmetic there is 4p plus 2q. And if I look carefully, I can see everything here is even. So I can divide by 2. 2p plus q is then minus 14. And there's our first equation. Now, because at this point we also have a stationary point, we're going to use the fact that we know that at stationary points, derivatives are 0. So let's say that. At this point, the derivative of my function is 0, where x is equal to 2, because it's at that point. So if I then go to my function and I differentiate it, now remember, we're differentiating this function up there. So our derivative here, f prime 2, I'm going to work with, and I know that that is 0. If I differentiate this function, I get f, let me not start with the f, let's just straight go for the derivative. The derivative of 2x cubed is 6x squared. You'll notice that I leave the x open. Plus the derivative of px squared is 2px. Then the derivative of qx is q. And then our last part, I think, was a 3. We know the derivative of a constant is 0. So this derivative must be 0 when x is 2. So I left the space for x to become 2. And now I'm just going to substitute, and then I solve this simultaneous equation. 4 times 6 gives me 24, plus the 4p plus q is thus 0, and I can kick this one to the right-hand side of my equation. Then I get 4p plus q is equal to minus 24. And that there, folks, is equation number 2, and that was equation number 1. Now look at this. If we take equation number 2, and from it we subtract equation number 1, then we're going to say q minus q. So we lose this q minus that q is gone. Okay, we're subtracting from the bottom. So 4p minus 2p gives me the 2p. Here I have minus 24 minus that minus, look at this now, minus the minus 14. Let me just, let me erase that part and just put the minus in. Minus 14. Okay, and that's a beauty of an equation. The only thing left for us is the p in that equation to solve. Okay, so what happens with that double negative? That's why I wanted to put the bracket down. I get that 2p is then minus 24. That double negative becomes plus 14, which makes 2p equal to minus 10, and then p is equal to minus 5. Let's see if that is what they wanted us to show. Yes, we can tick it off. Now we need to pray that q becomes minus 4. So we can put this into the equation number 2. So let's indicate the p goes into number 2. Then we have 4 times the p, and the p is minus 5, plus 4p, 4 times the p plus q is equal to minus 24. And then we get q being minus 24. This is minus 20. It goes over, it becomes plus 20. And indeed, q was minus 4. So again, if you did not get those two answers, or you didn't know what to do in this part of the question, please use those two values going forward to the next parts of the questions, folks. You do not leave it out because you couldn't find p and q. The second part is very interesting. They give us the coordinate of a point, and the point that they give us, let's go to the graph. They say this point A here has now got a coordinate pair minus 1 and 0. And now they're asking us to find the other two x-intercepts. Okay, so we can go straight to our graph. We have just solved these two variables. So we know that y is equal to 2x cubed. That was minus or plus px squared is now minus 5x squared. And here we had the plus qx, which is minus 4x, and the plus 3. Now remember, they told us point A is the point minus 1 and 0. So they've given you the root, folks, and you need to take that root and turn it into a factor. Okay? So we know the following. We know that x is equal to minus 1 is the root, so the factor will be x plus 1. This goes back to that side, to the left-hand side, to go and lie down with the x here. Okay, so all we need to do now is we need to be able to factorize this cubic over here, of which we know the one factor is x plus 1. And we know we've got to make this equal to 0 because we're finding x-intercepts. So our y-intercepts at those points are 0. Okay, we're going to be left with a quadratic, so we can do this with a quick inspection. X times 2x squared gives us the 2x cubed. Here I have plus 1. If I multiply this with a plus 3, then it gives me the plus 3 right at the back. Okay, so let's see, what else do I have? I have 2x squared. I want minus 5x squared. So I must take this 2x squared and I must minus 7x times this x is 7x squared to get to the 5x squared. So look again. I've got this part here. This is 2x squared. I want a result of minus 5. So from 2, I must remove minus 7x x squared. But in this bracket, it's an x multiplied by that x will give me the 7x squared that I'm looking for. Okay, so all that's left now is to factorize this. Let's go and factorize the second bracket. So we know we have x plus 1. This will be 2x and x, and this is a prime number 3. Factors of 3 is 3 and 1. I want a minus 7. The signs are the same. That's what this plus tells us, and it tells us that they're both negative. So a negative and a negative is naught. So then we can say the x value of A was minus 1. The x value of point B comes from this bracket. So it's positive 1 divided by 2. And then the x value for point C will be this value of 3. And these were the two that they were asking us to find. Now let's just see, they said find the coordinates. Please remember to put it in coordinate pair form. You don't want to lose a mark for that. So you can say that B is the coordinate pair 1/2 and 0, and that C is the coordinate pair 3 and 0. Okay, then they ask us one final question. They say, find the coordinates of this stationary point up there, the point D. Now we know that dy dx is 0 at the stationary point over here. So we go back to our function and we differentiate it and make it equal to 0. Let me just get us some space here. So for point C, I'm going to differentiate 6x cubed, 2x cubed becomes 6x squared, minus 10x minus 4 is 0 at the point that we're looking at, and that's at point D. So the derivative of the function is 0. Now before I'm going to factorize this, I'm going to clean it up a bit. I can see that every single term has a common factor of 2. So I change it to 3x squared, divide everything by 2, minus 5x, minus 2 is 0, and I have my two turning points. Now remember the 1 was x minus 2. They gave us the turning point F as the point 2 and minus 9, Mabutla. So we have 1 point. Okay, so we know we can factorize this with our eyes closed. There's a 3x short here to make up for the 3x squared. This is a minus 2. The product must be minus 2, so I must times it with plus 1. So there's minus 6 plus 1 is minus 5, which is 0. This is not what we're looking for. We're looking for the x coordinate of D, and that will be the coordinate pair that I found through this bracket, which is minus 1/3. Okay, so we still don't know the y coordinate. Now all we need to do is go back to the initial function. We put our minus 1/3 into the initial cubic function, and we find our y coordinate for D will be a funny number, 100/27. So with that, the coordinate pair is minus 1/3 and 100/27 at that turning point. Okay, Mabutla, I hope that that helped you. I think that the tricky part in this question was definitely the start of the question, where they asked you to prove those two things, or to show that the value of P and Q is minus 5 and 4. They only gave you 1 point, but remember they gave you a special point. It's a turning point that they give you.